Bismillah ar-Rahman ar-Rahim. Welcome my channel Real Islam TV. Here we were discussing previously the role of contribution of Muslims in mathematics. We discussed in previous chapter about the history of mathematics and contribution of Muslims in arithmetic. Today we will be discussing algebra, geometry, and trigonometry. So algebra is a word derived from Arabic word al-jabir and is the product of Arabic genius. Al-Khwarizmi, the celebrated mathematician, is also the author of Jabrul Muqabla, Hisabul Jabrul Muqabla, an outstanding work on algebra which contains analytic solutions of linear and quadratic equations. Khwarizmi has the distinction of being one of the founders of algebra who developed this branch of science to an exceptionally high degree. He also gives geometric solution of quadratic equation. Robert Chester, who was the first to translate this book into Latin in 1145 AD, which introduced algebra into Europe first time. Later on, this book was translated by Gerald of Cremona also. The algebra written by Al-Khwarizmi is lucid and well arranged. After dealing with the equations of second degree, the learned mathematician discussed algebraic multiplications and divisions. Writing in the Legacy of Islam, Cara de Vaux, its author, he says, in the 18th century, Leonard Fibonacci of Paris, an algebraist of considerable importance, say he owed a great deal to the Arabs. He traveled in Egypt, Syria, Greece, and Sicily and learned the Arabic method there. Recognized it to be superior to the method of Pythagoras and composed a Liber Abaci in 15th chapter, the rest of which deals with the algebraic calculations. Leonard enumerates the 6 cases of the quadratic equations just as Al-Khwarizmi gives them. The translation of Robert Chester of Khwarizmi's algebra marks the beginning of an era of introduction and advancement of this branch of science in Europe. The importance of Robert's Latin translation of Khwarizmi's algebra, says a modern Orientalist can hardly be exaggerated. He says that it can hardly be exaggerated because it marked the beginning of European algebra. Umar Khayyam, the celebrated poet, philosopher, astronomer, and mathematician, has left behind an excellent book on algebra also. His work on algebra was translated in 1851, while his Rohiyat were first published in 1859. The manuscripts of this principal work exist in Paris and in the India Office, London. Masdarat research on elucidates axioms dealing with the complicated arithmetical problems have been preserved in Munich, Germany. According to V. Minorsky, he was the greatest mathematician of medieval times. His primary contribution is in algebra, in which he registered much advance on the work of the Greeks. His algebra is an advance on that of Khwarizmi's too in the degree of equations, as the greater part of Umar's book is devoted to the cubic equations only. His algebra deals with the geometric and algebraic solution of equations of the second degree and includes an admirable classification of equations based on the number and different terms which they include. He recognizes 13 different forms of cubic equations. His solution of cubic and quadratic equations by the conic section method is probably the most advanced work of Arabic mathematics that has survived. His skill as a geometer, says Cardi Vox, is equal to his literary erudition and reveals real logical power and penetrations. Abdul Kamil, another Muslim algebra person, improved upon the algebra of Khwarizmi. He dealt with the quadratic equation, multiplication and division of algebraic quantities, addition and subtraction of radicals, and the algebraic treatment of pentagons and decagons. Another mathematician, Abu Bakr Kharki of Fakhrul Mulk in the beginning of 11th century wrote an outstanding treatise of algebra known as Al-Fakhri. This is one of the best books on the subject left by a Muslim mathematician and was published in Paris in 1853 AD. Now, another branch, geometry of mathematics. Like other branch of mathematics, geometry made much headway in the hands of Muslims. The three famous brothers, Muhammad, Ahmad, and Hassan, who were sons of Musa bin Shakir, wrote an excellent work on geometry which has translated into Latin by Gerald of Cremona. This was later translated into Germany by Kurtazov. Abu al-Wafa al-Basjani, who was from 940 to 997 AD, is the author of Kitab al-Hindusa, which was rendered into Persian by one of his friends. It had a large number of, says Schutter, geometrical problems for the fundamental construction of plane geometry to the construction of the corners of a regular polyhedron on the circumscribed sphere. Of special interest is the fact that number of these problems are solved by single span of the compass, a condition which we find for the first time here. Second mathematician Nasiruddin Tusi, a great intellectual giant of Islam, wrote Awaid al-Hinsiya, a book of geometry. It was much in advance of Hindus and Greeks in the development and use of arithmetic, algebra, and geometry, both three sections of the mathematics. The third person in this series comes Thabit bin Qura. He is the universally recognized as the greatest Muslim geometer. He was born in Haran and knew Greek and Syriac languages very well, so that he could read books of these countries in original. He wrote a number of short treatises on astronomy and mathematics. His treatise on the balance was translated into Latin by Gerard of Cremona. Al-Isfahani has contributed to conics. Isfahani also translated Greek works on conics. Next branch of mathematics is trigonometry. It has been universally acknowledged that the plane and spherical trigonometry were founded by Muslims who developed it considerably. The Greeks and other advanced nations of the ancient world were ignorant of this essential branch of mathematics, trigonometry. Khwarizmi, the Muslim mathematician, was made valuable contribution to this branch of mathematics also. His trigonometrical tables, which deal with the sines and tangent, were translated into Latin in 1126 AD by Adelard of Bath. Al-Battani, the nation of trigonometric ratios, which is now prevalent, owes its birth to the mathematical talents of Al-Battani. The third chapter of his astronomical work dealing with trigonometry had several times translated into Latin and Spanish language. Next in this list is Jabir bin Afiyah. He is the author of the celebrated book Kitab Ilahiyya, which deals with astronomy and trigonometry. His book Kitab Ilahiyya says Shutter is noteworthy for preparing the astronomical part with a special chapter on trigonometry. In his spherical trigonometry, he takes the rule of four magnitudes as the foundation